In this lesson, we will explain the basics in the transformation of grape juice into wine. Wine production starts from the berry of the grape. So think of a berry the way you would the earth. The earth has different layers. You have the crust, the mantle, and the core at the center. And these layers have different characteristics and functions. So the same applies for our berries. A berry has 3 layers, starting from the exocarp, followed by the mesocarp, and at the core of the grape is the endocarp. Let's look into the 3 a little bit more. The skin, or the exocarp, contains the largest part of the aroma and phenolics of the entire berry. Phenolic compounds are those responsible for color and organoleptic characteristics such as astringency and bitterness. Underneath the skin, we have the fleshy layer, which is called the mesocarp, and it contains mainly water, sugars, and organic acids. Finally, at the center of the grape, you'll find the seeds, or the endocarp, that contain mainly phenolics. In particular, tannins, which is responsible for astringency. Grape crushing is a necessary step to obtain juice. With a mild crushing, followed immediately by pressing, from the flesh we can obtain a juice rich in compounds such as sugars and organic acids. Sugars are the molecules that will be transformed by yeast into ethanol, while organic acids confer to wine its freshness. In the typical so-called white vinification, the extraction of the skin and seeds is avoided in order to prevent extraction of bitter and astringent compounds. While this process is normally used for white grapes, it can also be applied to red grapes, but in this case, a white wine is produced. Now, if you give a few hours of limited contact between the juice and the solid parts of the berries, you can extract a part of the aromatic compounds, which are mainly located in the skin. This last process is particularly important for aromatic grape varieties. On the other hand, in the red vinification, fermentation is performed through the contact of the berry skin and seeds, as this allows the extraction of phenolics that give red wines their color and structure. This winemaking is applied mainly to red grapes. Now, when applied to white grapes, it gives wines a dark yellow color and a structure higher than that of other white wines. At this point, to obtain wine from the grape juice, the intervention of yeast is required. These small cells belonging to the Saccharomyces genus, these are the same ones you find in brewers' and bakers' yeasts, they transform grape sugars, glucose and fructose, into ethanol and carbon dioxide. Generally, carbon dioxide produced by fermentation is lost in the atmosphere. But keep a mental note of carbon dioxide, as you will realize in subsequent steps how important this compound is in the production of sparkling wines such as Prosecco. Grapes harvested from a vineyard already contain wild yeasts on their surface. So after grape crushing, we can witness a spontaneous fermentation starting after just a few hours. In industrial wine production, however, winemakers generally prefer to use selected yeast strains, which guarantee a good and quick fermentation and a standard wine quality. Now, let me introduce some numbers before we move on with the winemaking process. 1 molecule of glucose will produce 2 molecules of ethanol and 2 molecules of carbon dioxide. Considering the different weight of these molecules, it means that 100 grams per liter of sugars will produce about 60 grams per liter of ethanol, or 6% alcohol. Regarding carbon dioxide, it is a gas, and so it tends to occupy large volumes. If we constrain it into a closed container, 4 grams per liter of sugars produce enough carbon dioxide to generate 1 bar of pressure. This means that the fermentation of a juice with 200 grams per liter of sugar, which is a very common amount, can potentially produce 50 bars of pressure. The transformation of sugars into ethanol is not the end of winemaking, but rather the beginning of a process necessary to prepare the wine for consumption. Before bottling, the winemaker needs to remove yeast cells by sedimentation or by centrifugation, and to remove unstable compounds from wine, such as excessive amounts of proteins that are usually the culprits of potential haze formation. In addition, the main organic acid of grape, that is tartaric acid, tends to precipitate during cold storage, giving unpleasant crystal formation in the bottle. A stabilization step is necessary to avoid this problem. Many different products of animal, vegetal, or synthetic origin are available to winemakers to stabilize their wine. After removing unstable compounds and stabilizing the wine, it is finally ready for filtration and bottling. Before we end this step on the process of winemaking, we must first talk about sulphur dioxide. You have surely heard of the presence of this molecule in wine. Why is it there? And what is its origin? The largest part of sulfur dioxide present in wine is added during the winemaking process. It is a molecule with many different properties. First of all, sulfur dioxide is an antioxidant compound, so it protects juice and wine from oxidation, a degradation phenomenon which occurs in the contact of wine and the oxygen present in the atmosphere. In addition, sulfur dioxide possesses antimicrobial activity. So while yeasts are relatively resistant to sulfur dioxide, spoilage bacteria are particularly sensitive to this molecule, making it a useful tool to preserve wine. During their metabolism, yeasts are able to produce small quantities of sulfur dioxide, and this is the reason why it is impossible to produce a wine completely free of sulfur dioxide. For the same reason, when looking for wines, you will never find on the label the sentence "without sulfites," but rather "with no added sulfites."